As artificial intelligence continues to reshape healthcare and athletic performance, its potential role in preventing running injuries is attracting growing attention. Imagine an app that doesn't just log your miles, but predicts your injury risk days in advance based on patterns in your gait, recovery, sleep, and even mental stress. The promise of AI in running injury prevention lies in its ability to process complex, multidimensional data at a scale far beyond human capability, offering individualized insight with unprecedented precision. But that promise comes with critical caveats. Without quality data, ethical safeguards, and real-world context, these systems could mislead more than they help. Machine learning models thrive on patterns. In theory, AI could learn to detect subtle shifts in biomechanics, heart rate variability, or muscle activation that precede injury, patterns too faint for a human coach or athlete to spot. By combining inputs like training volume, terrain changes, past injury history, sleep metrics, and psychological state, an intelligent system could flag high-risk days in advance and suggest modifications before a runner hits the red zone. This would mark a dramatic shift from reactive injury treatment to proactive risk reduction. But the success of this vision hinges on the quality and depth of the data feeding it. Many current running apps and devices rely on incomplete metrics, pace, heart rate, mileage, without capturing what matters most: tissue load, neuromuscular fatigue, emotional stress, and micro-recovery status. These missing variables are often the very factors that distinguish an injury-free runner from one on the brink. If the data is shallow or one-dimensional, the AI can only generate surface-level predictions that mimic the same errors seen in today's oversimplified training advice. Even more concerning is the issue of generalization. AI models are only as smart as the datasets they're trained on. If the data comes mostly from elite athletes or a narrow demographic, the resulting models may fail to account for real-world variability in body types, injury histories, gender-specific biomechanics, or cultural training habits. A system that works well for a 25-year-old male collegiate runner might produce dangerously inaccurate predictions for a 42-year-old mother returning to running postpartum. Bias in data equals bias in output, and when predictions influence health decisions, that becomes an ethical issue. There's also the question of accountability. If an AI-generated recommendation encourages a runner to push harder or rest when unnecessary, and that leads to injury, who bears responsibility? The user? The developer? The device maker? As AI systems become more autonomous in guiding training, the legal and ethical framework around their advice becomes increasingly murky. Runners may defer to the authority of the algorithm without understanding the assumptions behind it, especially if the app presents its output with certainty, but no explanation. Still, the potential shouldn't be dismissed. If done correctly, AI could be a powerful ally for injury prevention, especially when combined with human insight. The most promising systems will likely be hybrid models, using AI to detect patterns and flag anomalies, while still relying on coaches, physical therapists, or self-aware athletes to interpret and act on the information. These systems might not just prevent injuries, but educate runners in the process, helping them understand how sleep, nutrition, recovery, and stress all interact to shape training outcomes. To get there, however, developers and researchers need to prioritize transparency, personalization, and inclusivity. That means building models with diverse data inputs, regularly validating predictions in real-world conditions, and giving users access to the reasoning behind each suggestion. It also means setting limits, recognizing that no system, no matter how sophisticated, can fully account for the complexities of human movement and motivation. In the AI age, running injury prevention has the potential to become smarter, earlier, and more tailored. But that future will only be as strong as the foundation it rests on. Without careful attention to ethics, diversity, and data quality, even the smartest algorithms could lead runners down the wrong path. The goal shouldn't be to replace human judgment, but to enhance it, giving runners more tools to listen to their bodies, not fewer. When aligned with care and context, AI could help usher in a new era of safer, more sustainable running, not by eliminating risk, but by illuminating it.